Hello everybody and welcome back to another video. This video is for the Operating Systems Design course, CS621. And the purpose of this video is to go over to the next assignment. So I'm going to cover the next assignment, which is program number 6. So right now, this lecture is for the Tuesday 4/14 class meeting. And right now you should be working on assignment number 5, and I'm going to give you a little bit or more time this week to dedicate, because some people haven't turned in or haven't looked at some of the other assignments. You really want to start working on those assignments because all assignments are going to be due by 5/7. And so this week, your motivation this week is to get through assignment number 5. Turn in all the previous ones you haven't turned in yet, if that's the case. Do assignment number 5. Assignment number 5 is a little bit more difficult. That's why I'm going to give you the lecture stuff's going to be pretty lightweight this week to give you time. In fact, for this week, all you have is this lecture today, this one right now. I want you to spend the time, instead of listening to YouTube videos or listening to me, I want you to spend the time working on assignment number 5. So that's the agenda for this week. Okay, so assignment number 5 is hacking that Linux kernel, and it's writing. It's a couple parts. I went over this one already, so take a look in another video for the program number 5 description. Okay, so assignment number 6 is not due until 4:30. I want to preview this just in case some people have already finished, or some people have actually already finished assignment number 5, and you're looking for something new to do. We're going to do assignment number 6 review right now. So that one's not due until the end of the month. It's not due for another couple weeks. You have about 2 weeks on it. But you're going to have 7 due too. So, it's not a bad idea to start ramping up your assignments. Repeat that one more time. So anyway. And some of you have been asking about the final exam. The final exam is going to be in Blackboard. It will be timed. So it's not going to be possible for you to Google all the answers, but it'll be the same format, slightly different format, but very similar, and I'll have a video to go over that, but very similar to the midterm for this class. So I haven't written it yet, but it'll be designed the same way as the in-class midterm that you took. But this one will be given to you in Blackboard. It will not be multiple choice. It'll be short answer where you'll have to type in your answers. And you'll be given a limited amount of time with only one attempt. So as soon as you exit the exam, you'll have to turn it in. So I'll have some more information on that towards the end of the course here. So we still have about 4 weeks before that final exam. I'll have a review session as well before we get there. So this week is all about getting caught up on those assignments and getting everything turned in. So that's the focus of this week. All right, assignment number 6. Assignment number 6, here it is right here. So last week I gave you some videos to watch on memory allocation using malloc free, realloc, using the C functions, so you can get yourself familiar with memory. If you haven't watched those videos yet, I highly recommend watching those videos so that you are up to speed on memory allocation with malloc and free. So there's several different goals to this assignment. So in this assignment, you're going to write your own library. So you're going to learn about dynamic memory allocation. You're going to learn about tools that check the memory errors. You're going to learn about how the Linux signal handlers work for capturing error conditions. And you're going to write code that is a library. You're going to write a .h file instead of a complete program. Now, you might want to do a sample program that uses your library, but you don't have to do very much with that. So your assignment is to write a special version of malloc and free. So these library routines that check the common heap allocation and the usage mistakes. Your version of malloc and free will be called malloc2 and free2. So you're writing malloc2.h and free2.h, which are going to be implemented libraries, header files, precompiled headers that you're going to be using instead of malloc and free. So you're also going to write one extra function called memcheck2, and this is for checking if the heap allocation memory address range is safe to use. Okay, so we know that malloc and free don't do any error checking. That is one of the issues with this, actually, and so it could be potentially unsafe if you try to allocate something and then you try to use it after you've deallocated it or something, or you don't have enough room to allocate everything, or you're writing into something you haven't allocated. It's prone to errors. So what you're going to do is write a better version of it. You can use the underlining malloc and free functionality in your implementation. So you can write it on top of or sort of a wrapper to malloc and free. You do not have to reinvent the wheel. What you're reinventing or what you're creating is the accounting that's missing from malloc and free. So malloc and free don't actually have any accounting associated with them. And what I mean by accounting is keeping track of which memory has been allocated and which has been deallocated and what's available, etc. and so forth. So after you write your malloc2 and your free2, a programmer will use your versions of the malloc and free whenever they use the real ones. So your malloc2 and free2 will check to see if the operation is safe and makes sense, and then call the real malloc and the free to get the job done. Again, you do not have to reinvent the wheel. You are not rewriting malloc and free. You're calling malloc and free from your malloc2 and free2. You are using the real malloc and free to get the job done. So this means you're not reinventing the wheel unless you really want to. You're not reinventing the wheel. You are reusing the libraries that are already available. So in addition, whenever your program needs to access the heap memory, they will start an extra call to memcheck2 into their code to verify that the address range is valid. So memcheck2, which is your third one. So you're really writing malloc2, free2, and memcheck2. So here's some definitions of malloc2, free2, and memcheck2. So here's a description of the function that you're going to need to write. This is the function prototype. So in addition to actually allocating the memory, because malloc is going to allocate it. So in addition, and you're calling that from your function. So you're going to call it. So you're going to call malloc. This function will record a tuple. A tuple is kind of like a row. It's kind of like, it's kind of like a row in a database. It's kind of like a list, tuple. And it's not really a list. It has different components. But you're going to record it somehow. You can use any data structure you want. You don't have to use a tuple. You could use anything you want. You're doing it in C, by the way. This program is written in C. And so you're going to record a tuple for the memory that you allocate in the heap. So you get the starting address from the return value of malloc, the length, which is going to be length I. So you have the starting address and the length from the size parameter. And you can check the size parameter for 0 length. It is not actually an error, but usually enough that is worth reporting if there's no length, which means you haven't allocated anything. So you're going to keep a record. So malloc is going to run malloc. Your malloc2 is going to run malloc, and it's going to keep a record, or tuple, aka record, record it somehow. And you could put it in an array, you could put it in variables, you could do it any way you want. The address and the length. Now the free, your free2, releases it. So this function will first check to make sure that the memory specified by the pointer makes sense, that you're actually freeing something that has been allocated. And then you're going to call the free to actually do the free. To do the actual free. Some of the error conditions that you're going to check for in the free. Freeing memory that has not been, this should be been allocated. I'm having problems reading my own writing here, probably because my writing's bad. Free memory that has not been allocated with malloc2. So you're trying to free something that has never been allocated. That's a problem. or free memory that is not the first byte of the range of the memory that has been allocated. So it's not the starting address. It's in the length of the memory that has been allocated, but it's not all of it. It's only part of it. These are actually common errors that happen. So you're going to check for those in free too. Or free memory that has previously been freed, doing a double free. You can't free it twice. And if you do free, you can put an error message that comes back. And the way you're going to do this is you're just going to put messages to the screen. It says, sorry, you know, if the program tries to free something that's already been freed, doing a double free, so you put a message to the screen that says, sorry, this memory has already been freed. When an error is detected, then print out the details of the information in an error message and exit the program with status -1. And that's pretty easy to do. You just return -1. If all checks pass, then the function removes the tuple and calls free. So if the checks on the free work. Remembering these checks don't actually exist in the library, which is probably the reason why most of the time people call C an unsafe language, is because you can run malloc and free, and you can do all sorts of different, it's just like using pointers and, writing past the length of an array. You can do all sorts of stuff in C that is not appropriate, and it still works. So here we got another one, realloc 2 on your realloc. So if the pointer is null, this follows the specification of alloc 2 above. If the size is 0 and the pointer is not null, then this follows the specification of free 2 above. Otherwise, in addition to changing the memory allocation by calling realloc, so you're going to do another wrapper on realloc, this function will first check to see if the tuple has been removed, and then add a new one to basically reallocate it. And then you're basically doing the function again. So realloc can call free, or it can call malloc 2, just to reallocate. Memcheck, the other one, this function is going to check to see if the address range specified by the pointer and the length are fully within the range allocated by the malloc 2, and the memory has not been freed yet. It's just going to do a check. It's not a bad idea to implement the memcheck 2, which is going to run memcheck. That's basically just going to, it's going to run memcheck 2 actually, but it's basically going to see if the memory is okay. If the memory is okay, then we're going to proceed. If you're writing to something that's been deallocated, writing to something that has been freed, or writing to something that's non-existent, that's not in what we've allocated so far, then it should come back with an error. So when an error is detected, then print out the details of the information and then exit the program with a -1 status. And just return -1. So here's some code, some sample examples of how to use memcheck 2. So you're going to insert into your program. So you got a character buffer. You're going to allocate 10. You got a character C. You're going to malloc the size of the structure, and then you're going to check it. Check the buffer, the address of the buffer. And so when you do that, it's going to come back. Memcheck 2 is going to come back with a yes or no. If it's good, then you're going to proceed. So you're going to string copy hi mom into the buffer here. And then memcheck 2 is going to check the size of it. Then you can copy it and do whatever you want to it. So if you look at the videos that I gave you for last week, you'll see demonstrations on how to do memcheck and how to do realloc and alloc and free and basic C coding. So here's some code details and some testing. An important part of your program will be the data structure that will efficiently handle the range queries. As I was mentioning before, you can use any data structure that you want. So you can put it in an array, you can put it in you can make a tuple if you want. I don't know how you're going to implement it, maybe as a structure. I could do a struct for it. Store the data any way you want, which means looking up the address within the range, you'll need to look up the address. So this data structure, you're going to put the data in. Think about how easy it's going to be to read the data out of it as well. That's why the simpler you can go on the storing of the data, the easier it might be to actually read it. So this is not a simple data structure to implement efficiently. You're not being graded on your efficiency of the code either. And so it doesn't matter how efficient the program runs. If you use an array, or you put, let's say, structs or objects in an array, you can do it in C++ if you want. I do it in C though. It's just easier. It doesn't require object orientation. But think about it. Part of the battle is going to be deciding which data structure you're going to use. So you're going to write the module called malloc2.c with the 4 functions described above. This is the library that has those 4 functions that were described above. In addition, you're going to provide an include file, malloc2.h, with the function prototypes in it, exactly as described above. And these are the function prototypes for the functions. The functions are all in bold. So you've got 1, 2, 3, 4 functions that you're going to put, and you're going to put these functions inside of malloc2.c. You're going to send me malloc2.c, by the way. And you're also going to send me malloc2.h. So you're going to write, this is going to get compiled into a .o, a library file, and this is going to call it. So it's just, it's .c with .h. So this is going to have your function. The .h file is the precompiled header that's got your .h file that has your function prototypes in there. It's just like iostream.h or stdio.h, or better yet, malloc.h. But you're going to include malloc.2 that's going to call malloc.h from malloc2. So important, you should test your code with at least one test program by modifying the program to use the new heap routines instead of the standard ones, and then insert the memcheck2 whenever heap allocated memory is used. So write or go to the internet and download. You're not getting any credit for the main program, but you need to have a program that allocates and deallocates. So find yourself a little Hello World menu program, or use the one in the video from last week, and test it. So a program that uses malloc, and you're going to change the malloc to malloc2. And then in the program, you're going to put in the memcheck2 to check the memory before you start doing the malloc and the freeze. So what are you going to submit? You're going to give me the malloc2.c and the malloc2.h and your test program. You can zip them all together into one compressed file. I really don't care if you don't give me your test program though. I really just want malloc2.c and malloc2.h, which has the function prototypes in here and the source code in here. And the source code implements these 4 methods. So the quick and easy translation of this assignment, write 4 functions, put them in a file, and send it to me. But you want to test it, make sure it works. So email it to me like you normally do. I don't need the executable files. You can give me your test program if you want to. I'm not really giving you, I'm looking for these 2 here as the main component. If you send me your test programs, that's great. I can see that you've done it. If you want to, you can zip them all up, or you can put them on a drive, shared drive space or something if you want to as well. So this is assignment number 6. Assignment number 6 is not due for a couple weeks now. I should have left this up. Let's just take a look real quick. Just to refresh your memory. It is due on 4/30, and today is 4/14. This is the lecture for 4/14. And we have about 3 weeks. But I would finish number 5. I'd be working on number 5 if I were you. So spend the week, this week. This is the only video that you're going to have to listen to for this week. Spend the rest of the week catching up and working on these assignments. I'm not going to accept anything past 5/7. So right now, if you haven't turned in, I have some people who have not even turned in assignment number 1. If you have not turned anything in, you really got to spend this week catching up so that you can do 6 and 7. If you are caught up, you're doing pretty good, then you can work ahead on number 6. So next time, next week, I'm going to look at I/O systems and file systems, and we'll look at a little bit on distributed operating systems. I don't think we're going to get into the mobile operating systems too much, but I'll probably do like a lecture, a small lecture on mobile as well as distributed. So we have some miscellaneous topics, I call them, at the end. Stuff that I kind of leave for last. Sometimes I get to them, sometimes I don't in the face-to-face class. Usually I don't ever get to mobile operating systems. So, and then this last week is just going to be for review. So we are coming around the home stretch. So please start turning work in, and I will see you next week. And then, like always, if you do have a question, comment, concern, send me an email message. We can arrange a Zoom session or a Skype session, or we can email back and forth and I can troubleshoot your problems for you. I hope you guys are doing well and sheltering in place. The rest of the semester will be finished out online, and our final exams will be online through Blackboard, and they will be given during the final exam week as usual. They're not take-home. They're going to be exams in Blackboard. But I'll have more details on that as we get closer to the end of the course. So be safe, be well, and let me know if you have any questions, comments, or concerns, and use this week to really knock out assignments. All right, thanks for watching.